Welcome back to part 3 of our live training session here with our supercharged K-swapped NSX. In our last tutorial, we got our engine to fire up and run. We went through all of those details. This tutorial, we're going to be focusing on doing our part throttle calibration process for both fuel and spark timing. Also taking a look at going in and working with our fuel injection timing and our variable cam control for, again, part throttle cruise type situations. So this is the next order of operation after we get the engine to fire off and run and maintain a steady idle. We're going to have a lot to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our supercharged K20 swapped NSX. In the last tutorial, we got our engine to fire up and run. We went through the calibration process to validate our fuel and airflow model. We sorted out some spark timing and idle, but we ran into a problem with the idle control specifically. We were having a bit erratic idle control, and that was largely part due to the idle control motor being just too coarse of adjustment. So little duty cycle changes in our output to the idle control motor gave us too large of an airflow change. And as a result, we're finding we had too coarse of adjustment in the idle torque. To get the engine to idle at a desired idle speed, it requires a certain level of idle torque. Now we can achieve idle torque based on fuel and airflow. We can also have it based on spark timing. So in the case of working within idle control, we either move more airflow into the engine with an idle control motor, or we vary the spark timing to manipulate what the engine's torque production is going to be at. And we'll find that the airflow coming from something like our throttle stop or throttle opening or an idle control motor is going to be a coarse adjustment for the idle torque or the idle control. And then the spark timing is going to be more of a reactive fine adjustment. And we'll find that we can move our spark timing almost instantaneously with the Infinity and vary the engine's torque as a result almost instantaneously. But with the airflow-based style idle control, so working with an idle control motor, for example, it takes a little bit of time for the command to happen to open the idle control, to allow the airflow to start to flow through the idle control. So it's going to be a little bit laggy in terms of getting the engine's torque production right. So the way I typically handle idle control, I use the throttle body, if it's drive-by-wire, or use the idle control to give me the coarse or the fixed amount of airflow that I need for probably 80-90% of the torque production. And then I use the spark timing to achieve that last little bit. Now I've deleted the idle control motor because it was being unpredictable in that last tutorial. So now we have the throttle body that's just going to have airflow coming in based on the set screw or the throttle plate opening. This is going to be a fixed amount of airflow. So the goal here is to adjust the throttle screw to have the idle speed be higher than where we want it to be at. I want to idle about 1,000, 1,100 RPM on this particular engine because I have relatively large injectors, and that injector size doesn't perform very linearly and doesn't have good repeatable air fuel unless we're running a little bit richer air fuel to increase the pulse width, also idling a little bit higher. That smooths out the injector repeatability and the air fuel consistency and just the idle quality in general. But what we're finding here is that we want to idle about 1,000, 1,100. Now, what we need to do is actually have a little bit more airflow, a little bit more torque, well, airflow-wise, a little bit more airflow than we need so that when we're coming decelling back into idle, we're able to have the idle speed not drop down and stall. It'll catch itself, but we'll find that when we're idling in general, we're going to have maybe a little bit too much airflow than what we need. So we can use our spark timing feedback to actually bring down the engine's torque level to bring it to where we want to idle at. But off idle, as we're driving and we're decelling back into idle, we have more airflow. We have a surplus of airflow, and that'll allow us to not go into a stalling condition. It's kind of mimicking what we would accomplish with the idle control motor, where we would open the idle control motor a little bit on decel conditions to prevent it from dropping down so quickly and going into stalling. We can accomplish all of that with just raw airflow alone and using our spark timing feedback to be able to manipulate what the engine's torque production is going to do in almost instantaneously to get us to the desired target. So I've deleted the idle control motor from the previous tutorial. Now we're going to be firing off the engine in this tutorial, taking a look at what's going to happen with that IAC deleted. Now, we may have to adjust the idle set screw. That's setting the throttle plate opening or setting the base or coarse airflow amount coming into the engine. We might need more airflow because we've deleted the IAC. It was allowing a certain amount of airflow to come into the engine. We might need to go in and open that throttle plate more. Again, what we're probably going to be shooting for is looking for the idle to go up to about 1,200 when we're manually adjusting the idle control, and then using the spark timing to bring that idle down to where we want to be at, 1,100, 1,000 RPM. And then when we're driving, let's say normal part throttle, and we let off throttle and we're decelling down, it has that surplus of airflow, again, to slow the deceleration rate down, because we have no way to offset the drop down into idle if we don't have a surplus amount of airflow. We want to have that surplus airflow so that we can have surplus torque when we need it, just by moving our timing around. So hopefully that makes sense. So again, airflow coming through the throttle body or through the idle control motor, that's our coarse airflow, that's our coarse torque. The spark timing will be our reactive and our fine adjustment to the engine's torque. So let's go fire it off right now and let's just see what's going to happen. I want to revisit idle control real quickly here. And then we're also going to be just revisiting or talking about the post-start fuel, because the last tutorial we skipped over that because the idle control is just being a little bit too picky, finicky, and I just wasn't comfortable with going into the post-start fuel, looking at that on a warm engine until we sorted out the idle control. So we're going to try to sort it out real quickly, and once we do this in the beginning of the video, then we'll move into the part throttle calibration process. It's actually straightforward. We're going to look at how to dial in fuel and spark and variable cam and everything that goes along with that. And then we'll move on to doing full throttle tuning in the next tutorials, but let's get the engine fired up and going here. So I'm not going to go and hold my throttle open. I'm going to go fire it up and see where it wants to idle at by itself. If we take a look down here, the coolant temp is down to 132. It's sat for probably 30-40 minutes since its last ran, so it did cool down a little bit. So I'm going to go in here and do Control L, and let's just allow it to start to data log a little bit so we can keep track of what's going on. Let me go fire it off real quick here. Now, look what's happening. We're seeing that the idle... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.